Okay, Luis, thank you very much. It's great to be back at Toronto after many years. Thank you for calling me your friend. I took a long break of being a university director. And during this period, I discovered I lost lots of friends. So when you are into administration, you lose your friends. But when in your research, the friends you have not seen for many years are still your friends. So happy to be here. So I'm going to discuss some work. We're now completing the working paper on portfolio selection under ambiguity and the under-diversification puzzle. This was work with a PhD student. She finished her PhD a year ago. And in the process of writing the paper, we discovered that the problem was much richer than we originally thought. So we're about finished. I uploaded the slides if anybody's interested, and the paper should be in a form to circulate by the time I leave Canada. So what did we do in this work? We developed models for portfolio selection, robust portfolio selection, under differentiated ambiguity sets. We have two different ambiguity sets. You can think of them as the ambiguity of the home market and the ambiguity of the foreign market, the rest of the world. And that's an important starting point. I will discuss the literature to bring in ambiguity in explaining the under-diversification puzzles, which I will explain what they are. So develop robust portfolio selection under differentiated ambiguity sets. Importantly, ambiguity is a very rich concept. And I'm not saying this kind of hand-waving. It's in an econometric paper saying ambiguity is a rich concept. And rich in the sense that you need two things, two indices to measure ambiguity. One is ambiguity aversion, taste, characteristic of the individual, and the other is ambiguity perception, beliefs. What do people believe is the ambiguous? Okay. And I'm using ambiguity here in the sense of, it's naivety and uncertainty. We don't know the probabilities. Okay, so how averse am I in not knowing the probabilities? And what are my beliefs about the probabilities? I don't know them, but I have some beliefs. Okay, so our model includes both. We will show in the process that the model satisfies second-order stochastic dominance, consistency, which means that whatever I implemented on, I tested, which I will do, I don't have to worry too much about specifying a utility function. It's for whatever I come up with, it applies for a broad class of investors with concave non-decreasing utility function. So it's a nice property. I will discuss, we develop analytical solutions for the two-asset problem to show that the way we represent the problem, it leads to the conclusion that increasing ambiguity, either ambiguity aversion or perceived ambiguity, leads to under-diversification. But it's not mechanical. And this is an important point I want to make in our paper compared to existing literature. If you have a model that says increasing ambiguity always lowers diversification, and then you put it to the data, and you find that increasing ambiguity always lowers diversification, what have you proved? Have you established anything about the observed behavior, or you have just used your model, you just verified your model that you know what the model is doing? So an important point is that our model can generate, can work, can move you towards the ambiguous asset, not always away from the ambiguous asset. Now, this is an important point. If you have a model that can go either way, and then when you apply it to the data, it shows you that you always under-diversify, it means that the under-diversification is optimal given the data you observe in the market, as opposed to the behavior is optimal because my model says this behavior is optimal. And as a result of this analytical engine, we were able to link two puzzles, under-diversification puzzles, to perceived ambiguity. And the two puzzles is the home bias equity puzzle, which basically it's one of the considered one of the 6 puzzles in finance, which basically 90s they realized that the actual holdings of investors in foreign portfolios are much higher in the home market compared to what IKBM is saying. So if people want to diversify, and international diversification pays, as there are some serious papers, then how do you diversify? Well, if the well-market portfolio is the most efficient portfolio, you should hold in proportion the various markets. But instead, all investors in all countries, they are more biased towards home. And this has been called a puzzle. Why are people doing it? It's a very rich puzzle in the sense that many explanations have been coming up. Some natural ones, like transaction costs, have been rejected. Other natural ones, like diversification of income, like the previous speaker was talking about income, has been rejected. But then I will discuss some of the explanations. Okay? And we will show that ambiguity can fully explain the home bias puzzle in all developed emerging markets. Now, fully explain it, now I have to be a little bit careful here. I can always come up with a model and tweak the parameters and get the solution I want, right? It's okay, here it is. The question, as one of the most prominent surveys puts it, is can you explain the behavior, not just by having a model, but with reasonable parameters of the model? So we achieved 2 things in this paper. One, we have a model that is not biased. It could generate either one or the other. Okay? The second is we let the data speak. We don't have parameters to control, risk aversion or ambiguity aversion parameter. We let the data speak. What does it mean, let the data speak? We measure ambiguity based on data. We measure it in 2 different ways. There are different ways in the literature. We said, let's try one from each method. And we find that the model finds the home bias allocation optimal for ambiguity parameters well within those observed in the market. Okay, so the punchline is you have a model I will show you is not biased to create ambiguity because that's how I design it. To create bias, that's because I designed it. And it's explaining the observed behavior with parameters that are well within the range of parameters you have observed. Okay. And then the model makes a prediction if we assume that there is only a single ambiguity set, not 2, then this applies to another puzzle, related puzzle, the household portfolio under diversification puzzle. Households tend to hold fewer very few securities, so they don't diversify. And this has also been called a puzzle. There have been many solutions, many explanations offered, and a prediction of our model for the single ambiguity set is that you lower ambiguity. If you want to lower ambiguity, you diversify less. And we put this prediction to the data by a large database of US households, and we find we validate it. Okay? Here, we're not proving it to find a correlation, but here we show that it's optimal to hold the portfolios they hold. Okay. So the contribution is a parsimonious model of risk, ambiguity taste, ambiguity in beliefs and rewards. So everything that is taken into account in making a portfolio selection, which is the risk, is the reward, expected return, and ambiguity, tastes, and beliefs. We put them together in a consistent model, and I call it parsimonious because it does not have three parameters. Okay. And I like this cartoon from Hansen and Sargent, book on robustness. Beware of a theories bearing a three-parameter theta. I think this is the tattoo, is the model theories with the parameter theta, right? Presumably, you can prove everything, right? But of course, Kuber came in and put some discipline to these theories with a parameter theta, saying you want the parameter has to be reasonable. You are making a photograph of the cartoon. Okay, or can I move on? Okay. Okay, it's kind of first page of Hansen research. Now, that's one. Let me make a technical point, but important point. When I said that our model can move you towards ambiguity, not always away from ambiguity, why does it do it? And why others have not done it? One innovation, which I think we got lucky when we started doing it, we didn't think about it, but it turned out to be very important. We said, how are we going to represent ambiguity? And being kind of robust optimization guys, the robust optimization literature, there are two ways typically. One is interval ambiguity, that your parameters can be anywhere in the interval, so you create a box. But in our work, we usually do ellipsoidal ambiguity. So you assume that these extreme corners never happen. And there are reasons why people like ellipsoidal ambiguity. It can be formulated as a second-order cone program, Ben Tal and Nemirovsky. And for us, it was natural to do ellipsoids. Well, it turns out that we seem to be the only ones who did ellipsoids. And why is that important? It's not important in the technical sense. Okay, it's a new model, we will publish it. It's important because when you do the ellipsoidal ambiguity, the covariance matrix within the ambiguous assets appears. And once you have the covariance matrix of the ambiguous assets, now the issue comes up that if the ambiguous assets have low correlation or they are negatively correlated, you may prefer them. That's how we came up with a model that in theory can go either way, in favor of ambiguity, against ambiguity. And I will show you some experiments to demonstrate this. And therefore, when you put it to the data, we let the data speak. It's not built in the model that you always go away from the ambiguous assets. Okay. So you have this ellipsoidal. This is working. Okay. Ellipsoidal ambiguity accounts for asset correlations. Okay. Now, our main result, as the previous speaker said, in case you plan to stop following, let me give you the punchline. This is when we apply the model. I mean, apply the model to all developed and all emerging. Well, not all. There is a sample of 21 developed and 20 emerging that everybody's using with lots of data. We have applied the model to these 41, 42 countries. We can explain the observed home bias in all developed and in all emerging except Greece and Russia. And actually, Greece we explain with one of the two ambiguity measures. Okay, so what do you mean by explain? What we see here is on the horizontal axis, this is the ambiguity. Okay, this is the ambiguity. This parameter delta is coming from the data. So we estimate the size of the ellipsoid from data. It is usually around 7 or 8, it's somewhere out there with two different methods. And then we said for which value of the ellipsoid is the actual allocation, which are these lines here, intersecting the observed allocation, which is the black line. So the vertical axis is what you call the home bias. It's how much do you allocate in the home market compared to what I cap M says you should allocate in the home market. So if this is 0, you say, look, you're not allocating anything in the home market. If it's 1, you are allocating everything in the home market. And as you see in all cases, the line, the actual allocation is quite high because you allocate more in the home market than the IKBM is saying.
I don't understand the lines. Yellow.
Okay. Okay, let's first understand the axis and then we'll understand the line. Oops, what happened? Okay, so the x-axis is the ambiguity. The y-axis is the home bias, the relationship between what you actually invest and what the IKBM is saying you should invest. The black line is the benchmark. This is what you observe. So you see in our case home. And then we say, let's see what is the actual allocation coming from the model. So the lines, yellow, blue, and yellow, light blue, and dark blue are the actual allocations coming from the model. When we run the model for different values of delta, so we have a model that has ambiguity aversion. We say, okay, if delta has this value here, 2.5, what does the model suggest you invest? And then depending on the relative ambiguity between the home and the foreign, delta is the ambiguity of the foreign, the rest of the world. But then you have to consider the ambiguity of the rest of the world with respect to the ambiguity of your own market. This is the relative M is the relative ambiguity between the rest of the world and the home market.
Is that a free parameter?
No, it's not a free parameter. No, very good. No, very good question. It's not a free parameter. It's not a free parameter. We get it from the data. And I think the way we did experiment, we did one experiment where we assume this is specific for every country. And then said, let's assume every country has the average. And I'm doing here 3 to show that the result is robust. Okay. I mean, the critical question that people can ask is, how much do you believe these parameters? They are coming from data. Okay. So, and I will explain how we get them. So this is saying that if you look at different ambiguity levels of the foreign market, which we measure 2 different ways, and it's somewhere out there, it's like about 8 or 9 or 10. And when you look at the relative ambiguity between the home and the foreign market, which on the average is like 0.3, right, is the dark blue line, we find that if investors assume an ambiguity level of the foreign 2.5 as opposed to actual 8 or 9, they will allocate what you actually observe. Okay? And then I will show you later, it's the same for all the countries. So given the observed data, well within the observed ambiguity levels, it's optimal for investors to invest what you actually observe. So it's not really a puzzle. It's a bias. They are biased towards home, but the bias is optimal given ambiguity aversion, ambiguity perceptions, and a SSD kind of consistent model. So the outline of the paper, we are going to look at robust mean to CVAR portfolio selection. Why mean to CVAR? Because we like it, because we like STAR. We started working with CVAR many years ago, and because we don't want to start with normality assumptions. We said, let's look at something with stable distributions because data, international data are known not to satisfy normality. We could do other things, but we start from this one because we know how to set it up. It has some nice properties. So I will give you the mean to CVAR portfolio selection model. I will give the robust model with the differentiated ellipsoidal ambiguity sets, show you the SSD consistency, analytical solution in the case of 2 assets to understand the insights we get from this model, especially when it comes to diversification. We will show that the diversification moves in a certain direction with ambiguity, but also depends on the correlations. And this point is important. We will show you how the ellipsoidal ambiguity sets for correlated returns matters. Correlations are important within the ambiguity set. And then I will discuss how you obtain the results for the equity home bias in international portfolios and the household portfolio under diversification. Now, let's go back to the literature a little bit, understand how ambiguity entered into this literature of under-diversification puzzles. The first paper by Dow et al. In Econometrica 1992, they showed that ambiguity aversion leads to existence of price intervals for which a decision maker does not want to hold a non-zero position on an ambiguous asset. I mean, intuitively saying, if you have ambiguity, there is if you don't exact your probabilities, there is a range of values on the ambiguous asset for which you do not want to hold the ambiguous asset. Then Epstein and Wang, I think very important paper, established the existence of equilibrium process in asset pricing under ambiguity. So the first was more normative and building on the max-min axiomatic characterization of ambiguity aversion. They said, if you were to develop your portfolio selection based on this axiomatic characterization, there is an interval for which investors do not want to hold. And then they made the comment that this observation may help us explain the under-diversification puzzles. One of the manifestations of under-diversification puzzle is no participation. Why many people do not participate in the stock market, even if the data say you should. So it's the non-participation, it's the household under-diversification, but at the country level is the home bias puzzle. They are related. Epstein and Wang said there is an equilibrium process in asset pricing under ambiguity and suggests that equilibria may be indeterminate. And again, they point out that this observation may lead to explanations of the puzzle, but they leave it there. There was nothing in the theory to say that, look, we prove the puzzle. And of course, also an empirical question. Now, in laboratory setups, people have been doing experiments to find that investors or subjects that were ambiguity averse will diversify less. So in an experimental setting, we find it. Then there were some theoretical models, but also testable, like it's a model that you could put to the data, like a portfolio selection model, incorporating ambiguity in various ways, usually starting with the mean variance framework and say, let's assume that the mean return is ambiguous. And if you don't have non-negativity constraints, you get closed form solutions. And then you do sensitivity analysis of the closed form solutions, and you find that if the ambiguity changes or the ambiguity aversion parameter changes, you diversify less. So theoretical models are the most relevant for us is this very nice paper by Boyle, Garlapiou, Pal, and Wang in Management Science, where the title of the paper is Keynes meets Markowitz. And they said, look, Keynes talks about investing in a few familiar assets. Markowitz talks about diversification. How do you reconcile this view? And what they did, they have a model that one part of the model is the mean variance plus a penalty term for familiarity. And familiarity appears with a parameter alpha, which is the interval. If you know exactly the expected returns, the asset is familiar. And if you don't know the expected return, the asset is unfamiliar. And they show that by varying this parameter, you move more towards Keynes allocations. If alpha is large, you invest in a few familiar assets. And if alpha is 0, then Keynes meets Markowitz. You invest everything in the diversified portfolio. Now, what they did not do is to put it to the data, but the important thing, and I will show you some comparisons, is they do interval ambiguity. So at some point, as we were doing the work with the student and reading the literature, I said, so maybe there is nothing for us to do, except they are doing mean variance. And her first reaction is, yes, but you are doing CIVAR. I said, okay, that's fine, that's nice. I mean, you still get your PhD, but this is really an important contribution. Then in the process, we realized that interval versus ellipsoids is not only a technical innovation that you get a publishable paper, most importantly, is critical. And Boyle, and also Upal has a couple of other papers related to this, they do make the point that their model induces under-diversification, but does not explain the puzzle. Okay, so we have the theoretical models. Then we have recent empirical evidence on taste. Dimo, Kuenberg, and basically Dimo and Kuenberg, they published a few papers on this. They match surveys that include an elicitation of individuals' ambiguity aversion with data of individuals' asset holdings. And they find that more ambiguity averse individuals hold less diversified portfolios. So there is empirical evidence showing that ambiguity aversion is a determinant of under-diversification, and they have all kinds of controls, of course, in their test. There are papers that show that theoretically, if you put ambiguity in a model, it pushes you to move away from ambiguous assets towards familiar assets under diversification. But there was no putting that together. So what we did is have a model that can be put to the data, includes ambiguity aversion like these guys, includes ambiguity perception like these guys, because you need both, get it from market data and see if we can explain what has been observed. Okay, robust optimization. I mean, it's this notion of optimization under data ambiguity. We had written a paper with John Mulvey, who will be here tomorrow. And of course, the work on these intervals and the optimality conditions for robust optimization has been Tal and Nemirovsky. Our contribution was more to say, look, you have to look at all these optimization problems. If you don't know the data, you have to do like people in finance do, right? There is a variance term. So you need to put this notion of ambiguity has to be in the objective function, but also if you don't know the data, what about the constraints? And actually, George Danzig, in his book and his classical diet problem, he deals with this problem. He set up his diet problem using apples, and he says, but what is an apple? And he says, you see, different apples have different content of calcium. So how do you set up a linear program if you don't know exactly the content of the items in our diet? So basically, we said, look, you have to model this in the optimization problem, and Bental and Nemirovsky developed this whole literature of optimality conditions under ambiguity sets, and this is what we're still citing our own work, but we're using their model because it's mathematically more rigorous. It found applications in many areas: facility location, power capacity planning, disaster response, etc. It has been used in robust portfolio optimization. Gorfap and Diager in mathematics of OR were the first ones to develop a model, the mean variance model under ambiguity. It's a difficult question. Do you have ambiguity in the expected returns? Do you have ambiguity in the variances? Do you have ambiguity in the correlations? And then what kind of constraints do you have in the model? Like lots of papers have been developed from minimum variance to mean variance under ambiguity was a new paper, because having the constraint of the mean variance trade-off, having a constraint under ambiguity, is much more difficult problem to formulate and solve as a formulate as a second order Kohn program than if you have only ambiguous objective function. Okay. And what we did with Sommeiller, before actually she started her PhD, was to develop the mean CVAR portfolio optimization under ambiguity in the means and the correlations. The innovation was the correlation. Yes?
Yeah, I'm sorry, but I'm still not quite sure I fully understand what you mean by ambiguity. It seems like you're maybe using it to mean some slightly different things at different times, but maybe I just
okay. Let me define it. I mean, ambiguity is I don't know in which context you think I use it differently. Ambiguity is when I don't know the data, I don't know the probabilities. So Markowitz assumes you know the expected returns and you know the variance and covariance metrics. Ambiguity is when you don't know the probabilities. So our definition of ambiguity is here. Ambiguity in distribution. The distribution of the underlying whatever, like returns, is known only in the sense that it's coming from a set of probabilities that have with expected value as observed and the covariance matrix as observed. But you don't know the probability. Now, this is very general. So we go another step to be a little bit more precise of put some structure here. And this is the more constructive. The first one is very general. This one is saying that we don't know the probabilities, except that they belong to the set where the expected value of the random variable is R bar and the covariance is sigma hat. But then we said R bar is known only to the extent that it belongs to some ambiguity set. I don't really know R bar. Because if I know exactly R bar and I don't know from which probability give me this R bar, it's an easier problem. I don't know R bar. So R bar belongs to an ellipsoidal set with parameter delta. This is a free parameter, but I'll get it from data. So R bar satisfies this condition here. But this is ellipsoid. Now, we assume that we know sigma, but we don't know R bar. So R bar is within an ellipsoid centered to R hat. R hat is usually the estimated mean value. So what Markowitz or Dan and Stan say here is my expected return, that's the center of an ellipsoid. And the actual expected return belongs in that ellipsoid, and the ellipsoid has size delta. Okay? And I'm going to get the size delta from data using two different methods. Now, sigma, we assume it's known. Why do I assume it's known? Well, basically because you don't know how to formulate the problem if sigma is ambiguous, but also more fundamentally, we know that the problem in portfolio selection, the first order problem is ambiguity in the mean returns and not in the sigmas. Okay, so an ASTI referee can criticize with us about that, but the whole literature, most of the literature assumes sigma is known and R bar is not known. Okay. I mean, the two papers that have ambiguous sigma is Goldfarb and Younger for the mean variance model, and Sommeiller and myself for the mean CVAR model. So that's a reasonable assumption. So what we do, robust MTC portfolio selection. Okay, let me go back because I jumped to defining the ambiguity. So let's go back to the model. The model, we start without ambiguity first. So I have to start from somewhere. How am I doing with time? Okay. So the model is to maximize. Sorry. View. full screen mode. Okay. So the model is to maximize this mean to CVAR ratio, expected excess return over the CVAR of the excess return. Why do we look at this mean to CVAR ratio? This is a well-known reward measure for stable distributions. And we wanted to have one measure to optimize. It's a tangency portfolio. It's not somewhat of the efficient frontier. I mean, we could develop the whole thing with a trade-off between expected return and variance, but then we'll have to do our whole work with looking various points of the frontier. So mean to CVAR is a tangency portfolio on the expected return versus CVAR. It can be cast as a linear program, basically very similar tricks like Rockefeller and Duriasev. We could show that this satisfies SSD, so we can use this model to draw inferences. And we had to devise an asymptotic inference test. We have a paper where we developed this. And in order to use it, you need to draw inferences. And it turns out there was no statistical test. So we worked with a colleague, Paparodidis, who's a statistician, and you have an asymptotically valid inference test. So we start with a model that develops tangency optimal portfolios for investors with the correct utility function. We have an asymptotic inference test to draw inferences when we run the model under different settings. And starting from this, we go to the robust model. Now we're going to robustify this. We assume we don't know the mean values. They're going to robustify. So we develop the robust MTC portfolio selection with differentiated ambiguity sets for the mean returns of the home and the foreign. This is similar to what Boyle et al. Did for mean variance. We also have differentiated for home and foreign, except we don't need normality, but importantly is the ellipsoidal ambiguity sets. The second thing, ellipsoidal ambiguity sets to account for asset correlations. So here are the two ambiguity sets. The foreign is delta of the foreign assets, is the definition of the ellipsoidal set with the correlation of the foreign assets. For the home asset, there is only one. So the ellipsoidal actually becomes an interval. Okay. And the optimization model is the max mean, using the max mean criterion for ambiguity aversion, is to minimize the mean to CVAR under the ambiguous probabilities with the mean value of the foreign belonging to this ellipsoid and the mean value of the home belonging to this ellipsoid, which actually is an interval. Okay. And we want to find the portfolio that maximizes this value. So if you believe the axiomatic characterizations of Gilboa and Blyder, this is the model for an ambiguity averse investor under this kind of ambiguity. So the model properties is axiomatic max mean for ambiguity aversion. Ellipsoids account for perceived ambiguity of correlated returns. Now, let me tell you what is the problem with our model, which we don't know how to solve, but we know how to test that for robustness. Any PhD students here who are taking qualifying exams? We don't have the covariance between the home and foreign. And it's not just the technical thing, we don't know how to put it in, but it's not clear what it means to have differentiated ambiguities, but they are correlated. Okay. The way we're testing for this is we look at the case where we put the rest of the wealth is including the home market. So the correlation appears there. And that changes the results very little. So we look at And I mean, we have this assumption. Some of the papers assume zero correlation everywhere to get anywhere with ambiguity. So I think we made a big progress with this covariance here. We have the variance here. Actually, they have to be careful. When you see the model, the covariance between home and foreign appears, but appears only in the risk aspect. It does not appear in the ambiguity. Okay. So axiomatic max mean for ambiguity aversion, ellipsoids account for correlated returns. We will show that this is SSD consistent risk aversion. So this model satisfies the risk aversion of investors with the right utility function and satisfies ambiguity aversion for investors who obey the max mean axioms. It's parsimonious in the sense that we don't put in any risk aversion parameters or ambiguity aversion parameters, and can be formulated as a second order cone program following Bental and Nemirovsky, their Princeton University Press book. Okay, so here is the formulation. I mean, there are things like this term here is the ambiguity adjusted risk premium. No, this is the risk premium of the whole market. And this is an adjustment of the risk premium due to ambiguity. This is the ambiguity adjusted risk premium of the portfolio of foreign assets. So this function here is the adjustment of the risk premium of the foreign assets, but adjusted for the ambiguity and the correlations. And this is what the first paper in Econometrica was saying, that the choice will depend on the ambiguity aversion. So it appears there. Somewhere you see here is in the definition of the conditional value at risk, the correlation between home and foreign appears, okay, but not in the ambiguity aversion. Okay, the SSD consistency, assuming that the feasible portfolios have positive worst case mean excess return and worst case CVAR, then you can prove that the robust MTC is SSD consistent for all portfolios in X bar, X plus. Okay. I mean, the assumption basically is saying, I mean, if there is no positive solution, it means all these ambiguity adjusted variables are negative. If the ambiguity adjusted premium are negative, then you don't invest, the solution is zero. So it's not interesting. When it's positive, it satisfies second order stochastic laws. Okay, now let me walk you through a slide, which is kind of the essence of the importance of correlation. And then you can just go straight to apply to the data. How am I doing with time? Okay, how much time do you have?
Depends how much questions you want. So there's 15 minutes left.
Okay, I will try to wrap it up because I want to get some feedback there. Dan said, I don't want to miss my talk because he was very kind. He said, it's a very good talk. I said, look, I don't care if I miss my talk because I know it, but I don't want to miss the questions. Okay, so let's see what we see here. Here we look at this is our model, and these two are the models of Boyle and al., the management science paper. Here you have the home ambiguity and the foreign ambiguity and the home allocation between 0 and 1. Now, we assume that the correlation between home and foreign is 0.4, but the correlation between the foreign is minus 0.6, 0, and 0.6. So what do you observe? If the correlation between the foreign is 0.6, no matter what is the relative ambiguity between home and foreign, you do not invest in home. Because the two foreign have so much diversification potential that you stay away from home, no matter what is the relative ambiguity. This is your M. Like here you have 0 home ambiguity. So sorry, here. Yes, here you have 0 home ambiguity and 1 foreign ambiguity, but you don't invest in home. because the foreign have negative correlations. The moment you have zero correlation between the foreign or positive correlation between the foreign, the picture is changing. But let me get your attention for 2 points. You see that point P there? That point has zero homolocation, right? It's totally blue. Has zero homolocation, even if the home ambiguity is about 0.75, is lower than the foreign ambiguity, which is 1. And if we come to this here, look at this point P here. Now you have the home ambiguity is higher than the foreign ambiguity. Here, the home ambiguity is 0.5, the foreign is 0, but you still invest in home. So you can stay away from home, even if it's less ambiguous than the foreign, and you can go to home, even if it's more ambiguous than the foreign. If you look at the Boyle et al. Model, again, the same relative ambiguities like this. Now, in their case, they have, this is when the home has ambiguity 1, and here is where the home has ambiguity 0.5. So ambiguity of the home is lower than the ambiguity of the foreign, which translates to kind of points here below the diagonal. What you see going from this row to this row is that when the home ambiguity is lower than the foreign ambiguity, you invest in home, even if when both foreign assets have ambiguity 1. If you look at the corner there, both foreign assets are highly ambiguous. But because the ambiguity of the home is lower, you invest 100% in home, even if the foreign have correlation minus 0.6. And of course, this is increasing as the correlation is getting bigger. So the model here, it does create the bias. It does create home allocation in favor of lower ambiguity, which is what everybody's looking for to explain the puzzle. But in a way, also the model mechanically makes the allocation, or not mechanically. I want to be very careful because I like their paper very much, and Boyle was a mentor of mine many years ago, and Upal is a good friend. But there is something missing, which creates more under-diversification that's warranted by the data. So the advantage of our model is that it can give you point P here and point P here. It can go either way. Okay, so let's go to the data. Our model is not biased. Home allocation can be positive, even if home ambiguity is higher than the foreign, and the home allocation is 0, even if the home ambiguity is lower than the foreign. So it can go either ways. Ignoring correlations can generate mechanical home bias. Then we did the analysis of the 2 assets. In the 2 assets, basically, I think the interesting result is this one here, that we look at the diversification and we calculate the derivative of diversification with respect to the ambiguities. And we find that if you keep correlations constant, these derivatives are in the right direction. You increase ambiguity, you lower diversification. Okay, but the actual value depends on the sigmas. So the results, if you look only at the effect of ambiguity on diversification, is pointing you in the right direction, but you have the variance that may be pushing you in a different direction. And you have some simulations. Also here, another point I want to make, that how do you measure diversification? I mean, the standard thing is the differences of the weights from 1, but then Mitton and Fornick said, look, we cannot look at diversification ignoring the correlation metrics of the portfolio. So they have a more sophisticated measure of diversification. is not just having many assets, you are diversified, but if you have many assets that have the right correlation structure. Okay. So to be honest with our testing, or to be more stressful with our testing, we have to use diversification too. Okay. So let me go to the model prediction. So I've shown you these three-dimensional nice graphics, how our model can generate either direction. Let's now see what happens if we have a single ambiguity set. I take the model, we assume we have a single ambiguity set. Now, as you have a single ambiguity set, you have a large number of assets. You cannot boil it down to only two, because it's trivial. You need to look at the correlation, so you couldn't get a two-asset problem to get analytic solutions. We ran simulations, and what you see here is for both diversification measures, div1 and div2, is if you increase ambiguity, the diversification increases. Okay, or to put another way, if you want low ambiguity, you need to go for low diversification, for diversification measure 1 or diversification measure 2. So you see this relationship between diversification and ambiguity, and it's showing that if you want low ambiguity, low delta, our model says it's optimal to go for low diversification. And this is the model prediction that we are going to test on the household under diversification study. So the home bias, if you look at the measure, you see that historically it has been going down because of increasing market integration, but it's still quite large. I mean, for the whole world, it went from 0.85 in whenever down to 0.8. For developed is lower, for emerging is higher. It's going down, but it's there. Okay, it's not disappearing. Everybody agrees in the literature. So what we did, we take the actual equity holdings from the IMF coordinated portfolio survey. So this is the actual holdings. We look at the market capitalization. This is ICAPM, what the holdings should be if we believe the ICAPM, and data from data stream. How do we calculate the ambiguity? Now, two totally different ways. One way is more statistical. We look at multiple estimates of the expected returns using a rolling window. And then we say, okay, all these observations could be the estimate. And let's build an ellipsoid that includes everything we have observed. Okay, you can think of it in a sense that you do statistical analysis, you get a confidence interval, and you say, okay, this confidence interval defines where my expected value is, but we need an ellipsoid, and you have an algorithm with lot for doing that. The second method that Ait Sahalia and Sirkar from Princeton have been using with good justification, they are using this economic policy uncertainty index by Baker and Bloom as the source of ambiguity. You see, the reason you don't know the data is because there is this economic policy uncertainty which creates ambiguity. So we're using their method to kind of create intervals around the expected value adjusted by the measure of ambiguity for the different markets. This is available for every market. We get intervals, then based on this estimate, we feed the ellipsoid based on the correlation. So totally different ways. One is data-driven, the other is assuming EPU. And this is the original experiment. So I hope now it's clear what it's doing. Having estimated ambiguities two different ways, you have deltas two different ways, and you have a table in the paper that shows the delta of home and foreign for every country is somewhere like 6, 7, 8. With EPU is lower than with the data. Okay, we show that the intersection in all cases happens for a value of delta much below. We also look at the relative ambiguity, which is about the average 0.3, but some countries, I mean, like the US, has much lower relative ambiguity to the rest of the world. If you look at Cyprus, it has much higher relative ambiguity to the rest of the world. Okay, so intersection for all the countries. So model consistently generates home bias allocations that increase with increasing ambiguity in the foreign markets, decrease with increasing relative ambiguity between foreign and home, and what I have shown you is true for all other developed markets and from all emerging except Russia and Greece. So what you observe in the data is actually optimal for ambiguous averse investors given the market data. Let me go to the household under diversification just to show you. Here we calculate ambiguity again 2 different ways. One is data-based, the other is analyst-based. Now we don't have multiple markets. We have one market, the US. US households look at their portfolios. They are all selecting assets from the US stock market. And the way our friends in finance and accounting are telling us to understand the estimation errors is to look at analyst earning forecasts. The dispersion of analyst earning forecasts, and there is literature, is a good proxy of ambiguity. You don't know the actual value, and the analyst will give you dispersion. So using the 2 different methods, data-based, analyst-based, and here is what you see. We take the data from this huge database, we rank them by the number of assets in the portfolio, the diversification measure, and we look at the delta implied for data 2 different ways, data-based and analyst-based. And you see that the less diversified portfolios have lower ambiguity. So ambiguity aversion, as captured by the data in the US market, and as our model says you should behave, is reflected in the behavior of households. We also find in our analysis that diversification decreases where skewness goes up. I mean, a very important paper. So we're saying it's not just skewness that explains this under diversification, but ambiguity as well. And then we did the regression, of course. We said, okay, did we discover anything new? Or we're just rediscovering Midton and Dworkin. So we ran the regression, we are in the diversification, we put the ambiguity and everything else that matters. Standard deviation means skewness, the portfolio value as a proxy of the ability to diversify. Now we should put transaction cost. We have not done it yet. It's hard to calculate, but we will put it. We cannot put behavioral factors because we don't have data. And you see that in all specifications, the coefficient of ambiguity is economically and statistically strongly significant. So this establishes ambiguity as a determinant of the household under diversification puzzle. So I'm done. Thank you very much.
Thank you.